We're going to continue topic 6.13, and we're going to talk about improper integrals with infinite discontinuities. So this is the second basic type of improper integral, and it has an infinite discontinuity at or between the limits of integration. So rather than in the middle somewhere. I'm sorry, it is in the middle somewhere. So if f of x is continuous on an interval, has an infinite discontinuity at b, then that means that our infinite discontinuity is up at the top. We're going to just take c as it approaches b. And it means that it looks like something like we've got a picture where we're going like that. Okay. If f is continuous and has an infinite discontinuity at a, so the a is, so it's at the bottom part of the interval, it means it's probably something like that looks like that, meaning it starts with an infinite discontinuity. And then we also can have an infinite discontinuity somewhere in the middle, meaning it probably looks something along those lines, or it could look like this, where one goes up and one goes down. So in the first two cases, the improper integral converges, the limit exists just like it did last time, otherwise it diverges. Third case, if either one of them diverges, the whole thing diverges. So let's take a look at determining if the improper integral converges or diverges. We're going to basically evaluate this. We see that, let's look at a picture of what it looks like. So there's our function, but we notice we were only on the interval from 0 to 1. So I'm really just looking at kind of, I don't know if you can't really see my mouse, kind of at this piece of the graph. Hopefully you can see that piece of the graph, okay? So it's going up, 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 up. So that means that we have an approaching an infinite discontinuity from the right side. So I'm going to write my limit that way. The limit as b approaches 0 from the right. So this is what I'm replacing. So I'm going to say b. I could have probably said a. It doesn't really matter. To 1 of x to the negative 1/3 power. Remember, this is x to the 1/3. And then to bring it upstairs, I make it negative. And then dx. Pretty simple integral, so I'm just going to go ahead and integrate it. So the limit as b approaches 0 from the right of x to the, I add 3 over 3, so I get 2/3. I'm going to divide by 2/3 or multiply by 3/2. Then I'm going to evaluate that from b to 1. So now I've got the limit as b approaches 0 of 3/2 times 1 to the 2/3 minus 3/2 b to the 2/3 power. I know 1 to any power is just 1, so this first part is just going to be 3/2. I'm going to go ahead and substitute in my 0 because I might as well in this step. So 3/2, I don't need the extra step to do that, 0 to the 2/3. So this whole back piece is going to become 0. So my answer is 3/2, therefore this converges. All right, let's look at another one. So in example 7, we have an improper integral that diverges. So hopefully we're going to see one that diverges. If we're going to look at a picture of this one really quick. So this one you were supposed to be going from, let's see, it says 0 to 2. So let's isolate 0 to 2 on that. So 0 to 2, again, your infinite discontinuity is from the right side because it's going up, 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 up from the right. So I'm going to rewrite it as the limit as b approaches 0 from the right, from b to 2 of 1 over x cubed. Actually, I'm going to rewrite that as x to the negative third, or negative 3, sorry, dx. Okay, we're going to go ahead and do a pretty basic integral again. Limit as b approaches 0 from the right. I've got x to the negative 2 divided by negative 2 from b to 2. I am going to rewrite that once before I try to substitute into it. So it's really 1 over negative 2x squared from b to 2. Limit as b approaches 0 from the right of 1 over negative 2 times 2 squared minus 1 over negative 2b squared. Continue my work up here. I know that this first one ends up being negative 1/8. And then this is going to double negative is going to go positive 1 over 2. I'm just going to substitute in my 0. 0. The problem is that this right here, we can't do that, right? We can't have 0 in the denominator, so we really need to know what's going on with 0 from the right side. So as we're getting closer and closer and closer to this, so as that happens, as I'm getting closer and closer and closer to that value, 0, I actually end up getting to be a really giant number. It ends up getting to infinity. Because if I were looking at, let me put it into Desmos really quick. Let's just say I had 1 divided by 2x. It's not letting me type. Okay. So do you see the black that just popped up? As I'm getting closer and closer and closer and closer to 0, I am going up, 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 up. So that's the infinity. And then plus the 1/8, which is really negligible, or minus the negative 1/8. So therefore it's infinity. So therefore it diverges. I'm just looking at my notes again. And I'm noticing that I did try to put in like these values really quickly. So if I put in things that are close to 0 that I know I could put in like 1/2 if I put in 1. And if I put in 1, I would get 1/2. If I substituted in 1/2, which is even closer to 0, I know that I get 1. If I substitute in 1/4, so that would be 2, so it would be 1 over 1/2, which is equal to 2. Do you see I'm getting bigger and bigger and bigger? If I were even substituting the smaller numbers, I would get gigantic.